Good evening. For this project, we will be upgrading Yellow Group Inc.'s network infrastructure. From 35 to 96 is a big upgrade and will require servers, smart switches, more efficient computers, printers, and cabling. First, we have a modem connecting us to the outside world of information. Next, we have two servers. With a big network like this, you will need a server to take care of services like email, system logs, system updates, DHCP, DNS, to make the network run more smoothly. Next, we have the Layer 3 switch, saving you money on buying routers and switches. This right here gives us an all-in-one router and switch. Not just passing packets like a regular switch, but also routing packets to the modem, server, or internet, or any point of contact you need to pass information with. It's equipped with 24 fast Ethernet ports and 2 gigabit ports. Displayed here, giving you a total connectivity of 26 ports. When configured properly, will allow the computer to pass information more fast and proficient. Next, we have 96 workstations. All equipped with up-to-date business operating systems, given the employees business capabilities to be more efficient. All these 96 workstations are connected to a fast Ethernet port, Cat6 the standard, copper cabling for long-standing reliability and features. Also, we have 2 printers connected to our network for easy print reliability. All these 96 workstations cannot connect to one single router/switch. So we've deployed switches, sub-switches, and routers in groups. Here we have one main office connected to one switch connected to a printer. Here's another office with computers connected to a switch and a router, connected to the main router and switch that will enable packets to go to this printer or this printer on this side. Everything here is configured to be connected together. So let's start from the top. Up top we have a modem that connects us to the internet. Usually DSL or coax copper cabling is connecting the internet to your modem. From the modem is connected to the server. The server does exactly what it sounds like. It serves the computer with DHCP, giving it an IP address. 192.168.1 to 100 is our IP pool. File transfer protocol lets files being transferred. Email will have domain at yellowgroupinc.com. The network time protocol makes sure everything's in sync with each other. The system log, it logs everything happening on our network as far as packets being passed between device to device. Our DNS is our domain name server. Here I have yellowgroupinc.com for an example, and this is our DNS IP address. I already went over DHCP. This is our pool. HTTP I have off, and HTTPS I have on. HTTPS is a secure connectivity. It's a vulnerability to have it's a vulnerability to have HTTP. HTTPS gives us more secure connection with encryption. Our software and services for the server are business management operating system. Next, connected to the server, we have our main switch router. 24 ports, 2 gigabit ports, giving us a total of 26 ports. I've configured this in each Ethernet port, fast Ethernet port, and gigabit port to be connected to the other switches and routers. I've named it switch router main. I've saved the NVRAM, saving all the configurations I put into the switch in case a drastic power outage or something along the lines of that matter. It'll be easily accessible as a text document to be dropped back into our new router or given this router a backup. So if our router were to, for some reason, be unplugged, all we would need to do is turn it back on and boot this save document. So command line interface, where I put in the configs. I gave it this is our IP gateway. This is our subnet mask. Letting it talk to the server, letting it talk to the sub switches and routers, and also our backup server here. The sub switches and routers are configured the same. Different names, of course, and also saved. Configurations are saved. Also, each switch has the gateway IP and the subnet mask, letting them connect to each other. As you can see with the green dots here, it means they're talking to each other. From the sub switches, we have 96 workstations. Every workstation is configured with business operating system. It's given an IP from our server. We are on a 192.168 server pool. And that's our network. Every workstation is connected with the copper Cat6 cable, giving us reliability. Cat6 has become the standard for connectivity in a network for businesses. It's more reliable, it's faster. And it's long standing too. Anyway, like I said, every workstation is connected to a switch. Switch is going to the main switch, and the switch is going out to the router. The router is going out to our modem, which is giving us the internet. We can test some of these by pinging from one switch, from one computer to another computer. Let's do this one. Let's type in ping and one of our IP addresses to another computer, which is getting a reply, which is good. It means it's talking to that address. So as you can see here, the packets sent 4, received 4, and they lost 0. Pretty good connectivity. Looks good to me. Every printer is configured with the IP address, subnet mask, so any workstation here is able to print off of this printer or this printer if they want to walk across the hall to this printer. Alright, and with Packet Tracer, this is what I'm using, the Cisco Packet Tracer. It has a toolbar here where you can actually send packets, And let me bring up the bottom toolbar. Bottom toolbar is listed over here. It'll let you know if it's successful or failed. So let's click a packet here and let's send one to here, to here. Successful. Right, let's send one from this workstation to a server, which is also successful. This to that, successful. So it looks like we have a pretty successful network, and I think Yellow Group Inc. will be satisfied. 96 workstations, copper cable, printers, layer 3 switches, 2 servers connected to the internet. That concludes my presentation.